Hello guys, welcome back. In today's lesson, we are going to talk about transform stream. So let's get started. Here we have our transfer stream, and transfer streams are a special kind of duplex stream. So that's mean we need to take a look at the duplex stream first. So this, as illustrated here on the left side, we have a duplex stream. So duplex stream is readable stream and writable stream. So if you implement or create a subclass of duplex stream, you have to give underscore write and underscore read and some other mandatory methods for you to build your duplex stream, because duplex stream has writable buffer and readable buffer as well. So let's talk about the theory of the duplex stream. So kind of like a recap what we learned. So write something or write a data. So you can use write method, write your data from your application to writable buffer. And then internally for this duplex stream, so the data will be written to the underlining resources or underlay via underscore write. This internal method. So to the underlay. And on the contrary, the read, when we look at the read, so we underscore read the data. So first we have underscore read data from the underlining resources to the writable buffer. For example, you read duplex stream read data from the underlay to their readable buffer. Then as a consumer, you read data from this readable buffer to your application. Here is your application. So these two actions are independent. You read data and you write data. They are independent because there's a two buffer blocks here. So for when we take a look at the transform stream, because the special special duplex stream, so they just two buffers, writable buffer and readable buffer, internally just get connected together. So let's look at this. So data chunk written from here, or if you use pipe, that's the same effect. So data chunks has been was written to the stream buffer, to this transform stream buffer, and transform stream will transform or change these chunks one by one according to the underscore transform method you already given. So transform stream just change the original data to the data you would like to change to. So already transformed chunk goes to chunks go to readable buffer directly. So here's a buffer for writable. So buffer, this data will goes like this directly into their own readable buffer instead of instead of going to writable going to the underlay. So here, if you compare these two, so underscore write just put the data to the underlay, but for transform stream, that's here they put the data directly into their own readable buffer instead of to the underlay. That's a different point. And if the data has been sitting in the readable buffer and just waiting for your read method, you can use pause mode or flowing mode here. So to read out your data to your application, or I should say like this, you read out data to the next pipe or yeah. So that's the transform, what transform streams works. So in transform stream, so you have to give underscore transform and underscore flash two methods. They are mandatory for you to implement. So let's talk about pipe statement or pipe method, piping the streams, because this is many times we use pipe and to leverage by leveraging or leverage several transform streams. So let's talk about pipe. So pipe just if you are familiar with Unix or Linux, just as Unix and Linux command pipe. So you can pipe something. You can pipe a previous command's output into the second commands as the input. Then you can pipe again. So pipe just like this diagram, this picture. So you just put your pipe or just attach your every pipe with each other one by one. So your data will be processed one by one in order. So that means data for the first for the first chunk of pipe, data will be as the output, but for the second pipe, the same data will be as this input. So that means data will be flow through this pipe, the whole pipe. So when we use pipe statements, and we don't need to take care about the back pressure that we talked about before, and the pipe will be automatically deal with it with the pipe pressure. For example, if some of the pipe will get contracted or clogged, well, they will the previous one would be slowed down. So let's take a look at the example. For example, let's create read stream data from data CSV. So we create readable stream from a CSV file, and then we pipe the whole data into the CSV parser. So this CSV parser is a transform stream. So we transform the original data CSV data into the normalized one or organized data. So via the CSV parser, and then the result will goes into another stream, which is filtered by country, Italy. So we want to filter the whole data, filter out some of the data. For example, here by country, Italy, and then we just want to carry on processing with summary, give it a summary of the profit. So we kind of like this here, we have a doing the aggregation to give a final summary of the profit. And then we write out the whole summary into a standout. So that's a pipe example, just pipe lot of streams, especially in the middle, those are transform streams. So we pipe a lot of stream into the process steps. So we can get our whole mission done by using this kind of design pattern. So let's take a look at the example snippet, and for you to use this transform stream. So now we have a transform.js, and pretty I think this snippet is pretty simple, and you just create readable stream from a 100 megabytes file, and give it a variable rs readable stream, and you just create a writable stream with the name new file.txt, and just instantiate and give it a name, a new file. Then just define a new class and inheriting from the transform stream, which is uppercase. So we give a underscore transform definition function here, and you can see that we just grab this every trunk and transform all of the trunk into the uppercase. So, and then the console log in transform function or in transform method, and then we call back. You have to involve this callback, because if you don't call this callback, then all the underscore form will be paused. And as usual, you give a underscore flash, and this when the data, remaining data in the different buffers, in the transform buffers, internal buffers, will be flashed by using this method. So this is console log in underscore buffer, a flash. So if you hear this dot push, just like the usage or within the underscore read. So you push some data into the readable buffer. So this dot push, the uses of push is the same as when you define underscore read. So the same thing happens in the flash. This dot push. here we just push empty, no any parameter argument here. And yeah, just give it a pipe, which is rs readable stream dot piped into the new uppercase, which is our transform stream, and then pipe to the data will be piped to the new file, which is the new file.txt. So let's get started to get this rolling. Okay. The output is pretty simple. Just give you in transform and 64 kilobytes, because the readable buffers buffers length is 64 64K. If you use a fs create readable stream, the default length of buffer will be 64K. So every chunk is 64K long. So that means when within every transform procedure, 60K 60K byte chunk will be transformed. So I mean, so those are the same output, and then we all of a sudden we got the end. So in Flash, so the Flash remaining data from the buffer to your writable to your file. So that's it. That's everything for this short video. Thank you, guys.